start at the top of the page. This is review from what we learned in 10.2. It says find the measure of the arc or central angle. Go ahead and highlight central angle. So that means we're working with central angles. What do we know about central angles and their arcs? They're congruent. So congruent to their arc. What makes them central?
The points in the middle of the circle.
Yeah, the vertex is on the center of the circle. So today we're learning a different type of angle, and it is not like this one. Okay? But before we get there, we're going to solve these. It says, assume the lines that appear to be diameters are actually diameters. So let's start with LK. We want to find the measure of this arc. So what is helpful to point out in this picture? Arc IJ and JK, those are important. And then what from there? IJ is 41, JK is 89. What else is important?
IL is a semicircle.
IL is a diameter, correct, which makes a semicircle. That's okay. So how many degrees is a semicircle?
180.
180. So how do I find out what remains of the 180?
41 plus 89 minus 180.
Correct. So 41 plus 89, which makes 130. Subtract that from 180, and the measure of arc LK is 50. Yes, you do want a calculator out. The second one, we are finding an angle this time, angle SRT. We know the angle is going to be congruent to its arc. So if we find the arc, we find the angle because they're the same. So what is helpful to me to be able to find the arc? Two things are helpful. I just can't hear you. 114. What else is helpful to find the measure? We got a semicircle. We got a diameter, which splits the circle in half. So then how do I find the missing piece? Correct. 180 minus 114, which makes 66 degrees. Because if the arc is 66 degrees, the angle is also 66 degrees. Because what kind of angles were these? Central angles. Okay? So we're going to talk about a new type of angle, and it's called inscribed. Okay? So we're going to deal with inscribed angles and inscribed polygons. You're literally going to learn three policies, three theorems, and apply them. So you have a fill in the blank. It says an inscribed angle. Go ahead and write that it is an angle with a vertex on the side of the circle. So it is an angle with a vertex on the side of the circle. It is an angle with a vertex on the side of the circle. It is an angle with a vertex on the side of the circle. So the vertex is on the side of the circle. So different location, different measure. It's not going to be equal anymore. The other thing is an intercepted arc. We're going to use that word a lot. Sorry, it's going to show you the vertex and the sides of the angle. The sides of the angle are going to form an arc. Okay, you'll see it here. We call it an intercepted arc. What you're going to write is that it's an arc that lies between, or that is between two lines, rays, or segments. So an intercepted arc is an arc that's between two lines, rays, or segments. So it's an arc that is between two lines, rays, or segments. Did you write this down, Reagan?
Wait.
It is an arc that is between two lines, rays, or segments. So you're going to take one of your highlighters. Go ahead and highlight the word inscribed angle. This is the picture that you have. So we're going to highlight the inscribed angle in the same color. Okay, so highlight the word inscribed angle, then highlight the inscribed angle. What makes it inscribed is that B is on the side of the circle. Okay, and then the intercepted arc. Go ahead and highlight the word intercepted arc. And then highlight the intercepted arc in your picture. So it may be dumb, but the best thing that I envision, have you ever seen old school Scooby-Doo? Okay, and when they hold like a flashlight, it always looks like a triangle with like a little arc there. That's what I kind of envision. So you can do whatever you want, but that's what I see. So why does this matter? What happens here? The measure of an inscribed angle, you've got a box, you're going to fill it in, is half the measure of its intercepted arc. You're not going to highlight this. You're going to write something else and highlight it as well. So the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So here's what that means. We've got 3 things in this picture. Okay, we've got an arc. Give me a degree for this, an even number. An even number. 50 sounds wonderful. So here's what we have. If this arc is 50 degrees, there are 2 angles here. What do we call an angle whose vertex is on the center of the circle? A central angle. What is the measure of a central angle in comparison to its arc? Congruent. So what is the measure of this angle? 50. But we're talking about an inscribed angle, which would be this angle, sitting on the side of the circle. It is not going to be equal. It is going to be 1/2. So what is the measure of this angle going to be? 25. Okay, half of 50. So here's what you're going to write, and then you're going to highlight it. It's just something that you should, I don't want to say chant, but say over and over again. The angle is going to be half the arc, and the arc is double the angle. Go ahead and write it down, and you'll want to highlight it so that you can find it later. The angle is half the arc. So the angle is half the arc, and then the arc is double the angle. Angle is half the arc is double the angle. And then I would highlight it, and then we can go to page 2 for a second, and then come back to page 1. So highlight it, and then go to page 2 so we can apply it. So highlight it. The angle is half the arc is double the angle. So on page 2, you're going to find, there's 3 questions actually, but we're going to do these first 2, then go back to the first page to do the third. Go ahead and highlight which ones it's asking for. Just find the measure of the red arc or angle. Go ahead and highlight them on your paper so that you know which one we are solving for. We're going to find the measure of the red arc or the angle. So in number 1, are we finding an arc or an angle?
Angle.
An angle. What is the name, as in letters, what is the name of its intercepted arc?
G. Wait, G.
The name of it is HF. Okay? So if its intercepted arc is 90, we know the angle is half the arc is double the angle. So what am I going to do to 90 to find angle G? Divide by 2. So 90 divided by 2 is 45. And let me stop here to say, everything that you've learned previously still applies. What do you know about all of the arcs inside of a circle? They add up to 360. What do you know about a diameter? What does it do to the circle? Cuts it in half. So what is the measure of the top arc? 180. If you know this is 90, what's the measure of this remaining arc? 90. Okay, so all those things that you've learned before, they still apply here when it comes to the total arc. Number 2, we are finding an arc. Okay, the arc is the intercepted arc for angle U. So what am I going to do to find the measure of my arc?
38 times 2.
Perfect. 38 times 2, we're going to double, which makes
76.
76 degrees. Good. Go ahead and flip back to page 1 for a second so that we can do the third question. So we're back on page 1. This one will make sense when I put some numbers to it. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. Go ahead and highlight 2 inscribed angles intercept the same arc, the angles are congruent. So 2 inscribed angles intercept the same arc, the angles are congruent. And it makes sense when I highlight it in this picture. You already have these marked. Here's why this is the way it is. What is the intercepted arc for angle D? AB. What is the intercepted arc for angle C?
GY. GC. Wait, CB. CB. DC.
It's still AB.
Oh.
So you see how it touches the circle at A and B? They have the same arc, right? So if they have the same arc, they're going to have the same measure because we know the arc is double the angle. The angle is half the arc. So in order for that to work, they have to be the same measure. Okay, so when you go to the second page, we'll look at this question. Go ahead and go to the second page. You will have a question like this on your quiz. Are you okay, Thomas? Do you see how they both start and stop at A and B? We're finding an angle. All right, go ahead and highlight it because, again, this is the section where it says find the red arc or angle. It's not colored. What is the intercepted arc for angle X, the angle we're finding? ZW. Look at the 72. What is the intercepted arc for 72? ZW. They have the same arc. They're going to have the same measurement. So if angle Y is 72 degrees, what is the measure of angle X? 72 degrees. It's going to be the same. All right. Now we're going to talk about triangles. What's going to pop up on the screen is a lot of words, and we're going to highlight what's important of the words. So, inscribed right triangles. If a right triangle is inscribed in a circle, then the hypotenuse, this is the first blank you have. So if a right triangle is inscribed in a circle, then the hypotenuse is a diameter. Go ahead and stop and highlight that. The hypotenuse is the diameter. And highlight it in your picture just like it's highlighted in mine. So if a right triangle is in a circle, then the hypotenuse is the diameter. Go ahead and highlight it. So you've highlighted the hypotenuse as the diameter. You've highlighted it in your picture. Got both going for you. Okay, so conversely, if one side of an inscribed triangle is the diameter, just like so, then that means the angle opposite, which is your last blank, the angle opposite the diameter is the right angle. This is your last big blank. The angle opposite the diameter is the right angle. I'm going to tell you why you care. The angle opposite the diameter is the right angle. Inscribed right triangles.
Wait, what's the blank above the bottom?
First blank is the hypotenuse, correct?
Right, yeah.
And the hypotenuse is the diameter.
Mm-hmm.
Conversely, if one side of an inscribed triangle is diameter of the circle, then the circle is a right triangle, and the angle opposite, this was underlined, the angle opposite the diameter is the right angle. So, some things to know. The hypotenuse is the diameter, and it tells me where the right angle is located. In a normal right triangle, where is the right angle located? Always. Across from the hypotenuse. What is the hypotenuse in the circle?
AC.
AC. So it's just saying that the right angle will be across from the diameter. But the diameter is the hypotenuse, so it's across from the hypotenuse. You already knew this information. Okay, so the hypotenuse is the diameter, and the right angle is across the hypotenuse. You want to say diameter, doesn't matter. Here's what this will look like on a quiz or a test. You'd have a circle. One of the sides will be the diameter. And it would look like this. And it would say, this is 2x. Find the value of x. What do we know 2x would equal in this picture? 90. Why does it equal 90? What did we say? It's a right triangle because this is the hypotenuse. Across from the hypotenuse will always be the right angle. So that's what you're setting up for. Okay? Knowing that the right angle is across from your diameter. Okay, so we're going to go to the next page to practice it and then come back for the last theorem. All right, so we've got a triangle. In specific, what kind of triangle do we have?
Right triangle.
How do I know it's a right triangle?
Because the x is right across the hypotenuse.
Well, it's because one of the sides is the diameter. This is going to be your hypotenuse. It's okay, but you already know what x is. What's x going to be? 90. And then y, how do I find y?
40 plus 90 minus 180.
Good. What's 40 plus 90? 130. Subtract from 180 and you get 50. Good. You ready for the last thing? Go back to the page before. This next part is not hard at all. And if you get it wrong on a quiz or a test, it's because you didn't look back at it. It's talking about inscribed quadrilaterals. I haven't turned the screen, but you can go back to the second page. What is a quadrilateral? Has 4 sides. So inscribed means it's inside of a circle. Here's what happens. And you're going to highlight it. I think as well, write it down. It's inscribed if the opposite angles are supplementary. So you're going to write in that the opposite angles are supplementary. So the opposite angles are supplementary. And then I would highlight that. The opposite angles are supplementary. What does supplementary mean to me? They add up to 180. Okay, so what is opposite of E? G, so they would add up to 180. And opposite of D is F. They would also add up to 180. So now that you know that, D and F, E and G, go ahead and flip to the next page so that we can do the last 2 problems. So do we want to solve for x or y first? X. So I know that x is supplementary with 82. So x plus 82 equals 180. You can write it like this. You don't have to. You could just go ahead and subtract from 180. What does x equal? 98. So you can write it the algebra way, or you could just, subtract. What's 180 minus 68? 112. You can write it either way. If you want to write it like an equation, that's fine. If you just want to subtract, that is also fine. It works on a problem like this. They're both correct.
But every letter will be out of 180. I mean, not every letter, but
The angles opposite will be out of 180. They'll add up to 180. In the last question, you have to make an equation. Do you want to find x or c first? It's fine. C is fine. They're opposite of each other, right? So what do we know about the angles that are opposite each other? They add up to 180. So that's what we do. C plus 2c minus 6 equals 180. Combine like terms. 2c plus 1c is... I'm just going to go ahead and add the 6 to both sides. So 3c equals 186. Divide by 3. Correct. 62. And then last would be the x's. What am I going to do with them? Good. Add them. Set them equal to 180. 8x plus 10x is 18x equals 180. Divide by 18 and x equals 10. That's it. Sorry, it says x equals 10. You'll want a whiteboard marker. You can keep this out. All right, so you're going to do these in order. Do the question and then show it to me. Here's what you're doing on each of them. Decide if the angles given are central or inscribed. Then name an intercepted arc.
oh, so like
Correct. So you tell me if it is central or inscribed, and then tell me the intercepted arc. Correct. Correct. So look at where the vertex is to figure out if it is central or inscribed.
You can read that?
Correct. Today's date is the 23rd. No, 22nd. I'm just recording, so just don't do anything with the screen. It's correct. Good, and then tell me what's the intercepted arc. Correct. Pardon me? Yeah. I understand. Good. But you put line. How do we name an arc? There you go. That's better.
No?
One of them's wrong.
Wait, I'm good.
Yours is a no, and then one of yours is correct. Make sure you take capital letters.
Cap.
Yes, capital. Third one's correct. Okay, so the first one, where's the vertex?
L.
In the middle, the center, so we call that? We call it central. What is the inscribed arc, or what is the intercepted arc?
JK.
JK. Second one, where is the vertex? On the edge, so we call that? Inscribed. And the intercepted arc is? GF. 3, where is the vertex? On the side, which makes it? Inscribed. And the intercepted arc is? XW. Next one, where's the vertex? Neither. It's neither.
I didn't know that could be a.
Well, it's not. The options are on the center or on the side. Since this is neither, it is neither. The intercepted arc is still WX. Here's why this matters. On your quiz, it's not going to say you have a central angle. You're going to have to know. What do you know about the central angle and its arc? They're congruent. So if they give you 60 degrees, the measure of the arc is 60 degrees. But on an inscribed, if they say the angle is 60 degrees, what is the measure of the arc? Double, which is 120. It's okay. It's a Monday. It's not going to tell you the difference. You need to make sure you know the difference for your quiz. Okay? You're going to do the next one. You'll do them one at a time. Find the measure of angle A, and then find the measure of the arc. You can do them both at the same time if you're feeling confident. These are pretty quick. I know it looks like I'm not doing anything, but I am taking attendance. Both are correct. So remember what kind of angles these are, and then the relationship between the angle and the arc. Both are correct. So, did one of you take nice notes at the bottom? What, can you show me how you prepared it? So you squared it. You multiplied times itself. You didn't double it. So if you had $67 twice. Oh, sorry. Your math is a little. The first one, the math. Those are correct. And then the charges, man. Okay, so you're finding the angle. How do you find the angle?
84 divided by 2.
You half 84 and you get 42. You're given an angle. Multiply it times 2 and you get 134. These next two, you do have to find something before you find what you need. In this first one, you need angle G. What do you need to know before you find angle G?
What FD equals.
Yeah, you need to find the arc first and then find the angle. You already know how to find the arc? You learned that last week. Then once you know the arc, you can find the angle. Remember what you know about circles.
Okay, that makes sense.
I'll walk over here. Correct. Correct. The second one, John. Is it like if I have this open, you're gonna have an allergic reaction? You need to find the measure of the angle. Find the measure of the arc first, then find the measure of the angle. Good job. That's correct.
It's right here. It's right by her.
Oh, good.
360.
Oh, wow.
And me.
What you do?
That's good.
Well, I mean, you did that one
So this is. But the angle.
Got it.
But it's not 190. If this is 70 and that's 120, that makes 190. Okay, we can talk about it.
Wait, hold on, Ms. Marshall.
Wait, hold on.
Hold on.
In order to find angle G, you need to know the arc. But you already know how many degrees is the rest of the circle. 70 plus 120 is. So you already have 190 out of how many degrees? So subtract that and you get 170. So then how do you find the angle? Divided by 2 and you get 85. The second one, you can use the whole circle. What's important in this picture?
The diameter.
The diameter. So you know this is how many degrees?
180.
180. How much of the 180 do you have?
160.
160. So how much is left for that?
20.
20. But is that the measure of angle N? No, what is it going to be?
10.
10. It's going to be half that, so 10. Okay, these next two. What kind of shapes are these?
Quadrilateral.
Quadrilaterals. You learned a property about them. You're going to use that property. You sure did. You walked out of the room for that one. That's the one you should have written down.
So what's that?
X and Y. Correct. 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 Oh man, Ashton. It's interesting. One of each is correct.
We'll find out.
No, the other one's wrong. Correct.
Wait, both these correct?
What told me? Good. That's good. If you got the first, you can get the second one.
Oh.
Put this slide. I know it's really tempting to do that because I was in the book.
Oh, I didn't
You're
do
correct.
that.
You do the same can you do up here? What is the measure of that box? Don't remember the property. The opposite angles are something there. How many times is 3 going to 27? You put 3 times. Put 3 times 3 is 9. Okay, that's better.
Tripping.
Correct. I see you want to. Oh, 65 minus 1.
Stop it.
Will be correct. Correct. All right, so what do I do with opposite angles? Add them to 180, so 90 plus y. This one's easy, you could just subtract. What's 180 minus 90? 90. That's the first. The second, you got 81. 180 minus 81 is 99. For the second, what do I set up?
3 plus 3x equals 8.
Good. If I do this, what does x equal? 39. And then y, what do I do here? Equals 180, and y equals 29. Perfect. Okay, go ahead and find the question mark. There's 2 methods to finding it. Either one is fine. Sometimes it does help if you draw the picture. Correct.
Oh.
And then what do you do from there? So doing that, you found from here to here. You're not wrong yet. You're just gotta keep going. How do 2 angles out in this case? This isn't a quadrilateral. This is a right triangle. This is a triangle. So it's a right triangle. You missed it, but the hypotenuse is the diameter, which means the angle.
Yes,
opposite.
sir. And then Marsh this.
Did you subtract that from 180?
I know it just won't.
There are 2 ways to solve it. 2 ways. And I've seen both ways. I see this is a diameter, which tells me 2 things. If this is the diameter, what kind of triangle do we have? A right triangle. What kind of side is the diameter then? The hypotenuse, which means this is a right angle. So from here, I've seen a lot of people do this. If this is 70 degrees, what angle do we know?
70 divided by 2.
Yeah, angle K would be 35. And then you have, a triangle. So 3, add the 2, subtract from 180. I've seen, your math. I've seen that. I've also seen people find this angle, this arc, which is the intercepted arc for the question mark. How do you find the intercepted arc?
70 plus Plus 110.
Well,
Oh, well, 180.
180 minus 70, because this arc is 180 degrees. This is 110. So divide by 2, and that makes 55. Yep. So either way you had done it, you'd get 55. Both are correct. Okay? This next one, you're going to do 6 before you do 7. It says name 2 pairs of congruent angles. Pairs. So you're going to say these 2 are congruent and these 2 are congruent. This goes off of what we learned on the first page. If 2 angles have the same intercepted arc, then they are congruent to each other. What was our angle? That's not an angle. Yeah, 2 letters. When you name an angle, here you can name each angle one letter.
Yes, sir.
Times 1 pair. You need 2 pairs.
That's so cap.
That's good. Keep going.
Oh,
One
I'm
pair.
gonna go there.
Yep.
You.
That's better. I'll show you why.
Well, that's 2
Correct.
pairs.
Was that right?
That's correct. It's 2 pairs. Correct. Here's why. So pause. Let's look at angle A. What is the intercepted arc for angle A? BC. So the other angle would have the same intercepted arc. So angle A would be congruent to. What other angle has an intercepted arc of BC?
D.
Angle D. They both start and stop at BC. So angle A and angle D was the first one. The second, angle B, what is the intercepted arc?
AD.
AD. What other angle has an intercepted arc?
C.
C. Angle C. Those were the 2 answers. Okay? Go ahead and continue into the second, which we should be confident about by now.
Oh my God.
Correct. Correct.
I'm going
No? Correct. Did you do both of them?
No.
Find and okay, that's correct. Do you not have a second marker? Yep. You do it good? I shouldn't see a trail. There sure is. Last week I was wanting trail mix, and I was like, I'm just going to buy it from Sam's. 4 pounds of it. What was I thinking? Well, here we are. Good. On number 7, what kind of shape do we have inscribed into the circle?
A quadrilateral.
What property did we learn about quadrilaterals?
Add 360. Oh. A triangle adds up to 180.
You sound stupid. There's something in it.
So we're okay. So let's just beep it back. Okay. All of the angles do add up to 360. He's not wrong, but you're also not right either. That doesn't help me here. What adds up to 180? The opposite angles will add up to 180. So n and 100. So n equals 80, and 65 and m, which makes 115. Good. This next one, I believe these are the harder questions. So I'm going to help you. I would draw it first. I would draw it first.
What? No, no.
We have to find all the letters.
Yes. You can draw it smaller so you have room to do stuff. It's just a circle with a quadrilateral in it. Just relax. Draw a circle with a quadrilateral. We will all be okay. You can definitely find A and B very easily because those are angles, right?
Yeah. But
So go ahead, just plug in all the numbers, all the letters, all the things. Once you've drawn it, just go ahead and find A and B. That's correct. And B. You'll want to keep those numbers, though, so write it off to the side, because you need them to find the other things. Where'd you get F and H from? Oh. I see. It's just A, B, C, D. Good. And then I think that one was good. Yeah. Just find the angles at the moment. Find A and B and then write them off to the side. And then look at me when you're ready to find the rest. Good. Now write them off to the side, A and B. Here's what you need to notice. Good. I'm not going to give it away. I'm just going to go around and show you what you would do. Good. You should get A is 88 and B is 100. Remember what you learned about intercepted arcs. So here's 88. What is the intercepted arc for 88? What's HF, right? So you know how many degrees it adds up to. However, you can't do anything else because you don't know E and you don't know F. But you can keep going around the circle with the angles. Angle F, or B, however you want to say it, is 100 degrees. So what is the measure of its intercepted arc? It's GM, which is how many degrees? 200. Do you know a piece of the 200? Yes, you know this piece, right? So then you can very easily find E. Keep going around the circle with each angle. Find its intercepted arc. You see what I'm saying? So use the angles to find out how many total degrees the arc would be, and then subtract what you have of the arc. So keep going. I would find them in the order I wrote them in. A, B, C, D, E. So I would find C next.
Wait, hold on. If we were trying to figure out 92, how would we do that? H, would it be H?
So 92, this is the angle, right? So the intercepted arc is this whole thing. So since it's an inscribed angle, what do we know about the inscribed angle and its arc? Times 2. So you know the measure of the full arc. You can subtract what part of the arc you have to find what part of the arc you don't have. You can find all of them. Because once you find C, you can find D using the same process, just a different number. C, so what's 92 double?
F is an angle.
Yeah, so of the 184 degrees from H to F, you have 120 of it. So to find C. So if you combine these two, what angle does it correspond to? I didn't hear you. Well, I'm saying this one. C was right. So if you combine these two, what is the inscribed angle? So then what's the measure of this whole arc? You have that many degrees of You didn't find each individual letter. Is that the second one? Did you erase it? Give me a second one. Okay. No. Okay, let's look. Let's start with C. Is there an angle that starts and stops at C? That goes in like this? No. But C is next to 120. What angle is the inscribed angle for this arc? M, right? So what is the full measure of this arc if M is 92 degrees? What's 92 times 2? That's how you find the... It's 184, right? So of the 184, you have 120. So what do I do to find this missing piece? 184 minus 120, which is 64. Okay, keep going around the circle. You've got C. You want to find D. What is the inscribed angle for these two? H. So if angle H is 80, what is the measure of its intercepted arc? 160. So then what do I do to find the measure of angle D, or arc D? Correct. Which is what? 96. I want you to find E. You're answering both of these before you switch over to lunch. Yes, you're correct.
I can erase it now.
Yes, you're good. Last one, check one. Never mind, we'll check one. Yes, so do this.
What, how many times do you-
So now do the second. Got it? Good. I'm on the second. No, because I haven't made either.
The
You won't
second
come out
one,
with
like the second one?
The second one, you're doing the whole second problem once you got the first one down.
Lunch food is so good.
How'd you get 4? No. So what angle do I look at to find E? Which of the inscribed angles do I look at to find E?
H. Oh, E, yeah.
You can look at either one. Sorry, I didn't understand. You can look at F. This one will actually be easier. What is the measure of the arc going to be? 200, right? Because 100 times 2 is 200. Of the 200, you have 120. So how much is left for E?
80.
80. Sorry, I was thinking of this one, which would work as well. Double this, subtract 96, and you still get 80. Same thing. Make sure you're doing the second question.
Wait, I have
Yep, and then you do the second question, and then you're done. Yes, ma'am. Trent. Just C. I think. No, and D is wrong. Draw it. I can't do that. That's A, yeah. This one's easier because you don't have to combine any angles. So start where your information is. If this is an arc, right? What is the angle that corresponds to the arc? Then use that, find that angle. A is correct. You're correct. All right. Correct. And then yellow, Ashton.
Yes, Marshall.
Okay. Beggars can't be choosers is correct. Okay, with the second one, where do we want to start? What information? It's not a quadrilateral, so the angles aren't opposite. They don't add up to 180. Where do we want to start? What number do we want to start with? 59 or 138? 59. It's an angle, correct? What is its intercepted arc? A. What do we know about the angle in comparison to its arc? It's double. So A is 118. What other information did we start with? 138. Which is an arc. What is its angle? Angle B, right? So what do I do to find angle B?
138 divided by 2.
138 divided by 2, which is 69. All right, so then how do I find angle C?
138 plus 118 minus 360, that finds D, and then whatever D is divided by 2.
Yeah. 59 plus 69, which is 128. Subtract that from 180 and you get 52. Right? And then what can I find now that I know that angle C or Z, however you want to say it, is 52? Yeah, D, because it's the intercepted arc. So what do I do here to find D?
52 times 2.
52 times 2, which is 108.
Can I get my lunch?
Yes, you may go get your